The next chapter is classification trees and regression trees. So in short, it's called CART, CART, and we will be using several libraries for one for regular uh, decision tree and then one for random forest and boosting. So there are lots of different approaches that are possible with the decision tree. So we'll look at examples of those. First, let's set the default path to the data files. Then we will activate a bunch of libraries. Okay, uh, rpart, rpart.plot. Okay, these are for decision trees, and then uh, add a bag is for boosting decision trees, and random forest is for random forest decision trees. Then caret is for control. I mean, you can use caret with rpart, and you can set up parameters to fine tune the decision tree. And then PROC is for ROC charts. Forecast is for generating confusion matrix or performance measures, and gains for lift charts. All right, so let's go ahead and run these libraries. So we'll start with the example that is discussed in your text, the lawnmower example. So that will be mower.df, and we'll read the file riding mowers. Riding mowers CSV. So that's done. Then running our tree is quite simple using rpart. Okay, so we're going to use class.tree is where we're going to save the results from running the decision tree. Right, we're going to use rpart, and we can look at rpart help page. Okay, and then here it is, the help page. See, the first item is formula, and then we give data, and the third thing that is required is method. So those three things we have to specify, the others are optional. So our data here is ownership is target, the other two are the predictor. So our formula is ownership tilde and then dot for all the other variables. That's our formula, and then we give data is mower.df, and then method equal to class, and then we'll see what it contains, right? So we run the train code, and then we'll run class.tree, and it gives you the nodes. So that's our root node, and then the left side node and the right side node. So it doesn't give you a plot, and for that we have to run the plot code procedure. Okay, and the rpart itself has a couple of more options. Remember, these are the three that we have to provide. There are a couple of other options that are useful, and we will go over those in a little bit. And here, okay, the procedure for plotting is PRP. Okay, so PRP is the uh, procedure from rpart.plot library. Okay, and then again there are lots of options that we have, but if you don't specify any options, okay, all the defaults are used. All right, so you could run that, and you see the root node, and then the second node to the left, then the third node to the right. So this is the basic tree. It doesn't give you a whole lot, but if you add some more options, like if you say type equal to 1 and you run that, then you see it adds some more information. Again, you can uh, look for help in PRP, right? So here is PRP. It tells you that it has a whole bunch of options available, but here you have the type. Okay, so what are the different types that are available, and you can experiment with that. And then the second one is extra equal to, so let's say 1. Okay, so if you do that, then you get additional information like how many events and how many non-events. And then once you branch off for each node, you get the events and non-events. And if you go back to our help, then you see there are a whole bunch of extra that are available that you can specify. So if you do like 104, so you get uh, percentages. So you get the percentages of event and non-event, and then it tells you how many observations in percentage terms from the data set is in that node. So here 33% says, okay, this branch you have 33% of the entire data set, of which 87% is non-owner, 12% is owner. Okay, so here 67% of the observations, 31% owner and 69% non-owner. Okay, so I'm going to put it back to type 1, extra 1. Okay, so we generated this tree. Now let's look at how to generate this one. And here we're going to look at couple of options like the depth and the minimum number that we want for the splits. See, save this in the same object class tree, right? And or part ownership tilde dot comma. So that's the formula. Now, data equal to mower.df, method equal to class. So that's the basic tree. Now we can specify some additional options. Suppose we say min split equal to, that is in a split, okay, what is the minimum number of observations you want to have? So you limit the number of splits this way. So you can say I want at least 5 observations or at least 10 observations and so on. So this data set being so small, let's say min split is equal to 2. Okay, and then we will use this PRP to print the tree. Okay, so now we have, this is the tree that we get with minimum split. Okay, so if you look at the textbook, so this is what we have. So we can see the tree.